And for the blue line, we see that it's a positive slope, and the base, or the y-intercept, is 1. And it's going from left to right. All right, last bullet point for DOK2. Create an equation based on the following table. So you have x, 1, 2, 3, 4, and then y is 9, 14, 19, 24. All right, so this is a linear regression because it's going up steadily, not exponentially. So we're going to use the linear equation y equals mx plus b. Okay, so the first thing we need to find is the slope. Remember, the slope equation is y2 minus y1 divided by x2 minus x1. So we can pick any two set or order pair and plug them into that equation to find the slope. So this is going to be my y2, my y1, this is my x2, this is my x1. So it's 19 minus 14 divided by 3 minus 2. 9 minus 4, that's 5, so 19 minus 14 is going to be 5. 3 minus 2 is 1, so the slope is 5. Okay, so now once you find the slope, you can use this equation to figure out b. So if you write the equation out again, y equals mx plus b. We can pick two any order pair, plug them in for y and x, and plug in m and solve for b. So I'm going to use this pair here. This is going to be my x, and this is going to be my y, and I know my m here. So when I plug those into my equation, it's going to be 9 equal to 5 times 1 plus b, which is going to be 5 times 1, which is 5. 9 equals 5 plus b. Then you're going to subtract 5 on both sides. 4 equals b. So now I have my m, now I have my b, and I just write the equation again. Y equals mx plus b. Y equals 5x plus 4. And that's the equation for the last question of DOK2. Okay? And that's the last question for DOK2. All right, create a table for the values of an equation modeling the following information. The athletic club at school accepts 5 new members each week. After 6 weeks, it has 37 members. Okay, so we know that weeks, which is a unit of time, that's always going to be the independent variable. So that's going to be on your x-axis, or going to be on the left side of your table. Okay, and then we have members, which is going to be your dependent variable, or on your y-axis. All right, so we're just doing the table. So we have weeks, and then we have members. Okay. So it says the athletic club at school accepts 5 new members each week. So for the first week, we have 5. Second week, we have 10. Third week, we have 15. Fourth week, 20. Fifth week, 25. Sixth week is 30. Now I know it says after 6 weeks it has 37 members, so that would be 7. So that would be 35. So that's roughly around 37. So this would be the table for that part. All right. Second bullet, this is the graph. So the second bullet point for DOK3. So this is all DOK3. So the first column is the first bullet point for DOK3. And shows the graph to the right and claims this relationship must grow 2 units on the Y and change 2 units for every 1 X value. Do you agree with her and why? So what that means, it says if you're going up on the Y and then moving to the right or left, that's called rise over run. And rise over run is just going to be the slope equation. Okay, so we've got to pick any 2 Y values and 2 X values and plug them in the equation. So I'm going to pick the very first point at the top. So I believe that's 7 and -1. Excuse me, -1 and 7. X value is -1, Y value is 7. And then let's do 2 and 1. Okay, so this is going to be my X. Let this be my X2, Y2. And let this be my X1, Y1. So Y2 is 7 minus Y1. X2 is -1 minus 2. So it's going to be 7 minus 1, which is 6, over -2 minus 2. So that is going to be -3. So when we simplify this, 6 divided by 3, 3 goes into 6 2 times, 3 goes into 3 1 time. Remember, it's negative. So if you read it again, it says this relationship must grow plus 2, so that's my rise, for every 1 X value. Do you agree with that? Yes. And that's because the slope is 2 over -1. Okay? That's the second bullet point for DOK3. All right? Which of the following situation models a linear relationship? Justify your claim if the relationship is linear, create an equation matching the situation. All right, metro workers are testing the newest train. The record is distance over time of the following table. So we have, you can really just graph this one to see if this is correct. So we got 0.5, because that's time. Time is the independent variable. 1, 3, 5. And then for that, distance is 0.335, 0.67. This is 2.0, so that's all the way up here. Let's say that this is, let this one be 0.75, and then 1, and then this one here, I'm going to make it 3, and then 5. Technically 3 would kind of be up here. Okay. So when we graph this, we got 0 with 0.5 with 0.33, 0.5 with 0.33, so that's right here. 1 with 0.67, 3 with 2, and then 5 is 3. So this is linear. Okay. So if it's linear, that means it has a y equals mx plus b equation. So we see here that the base, where it starts at on the y-axis, is at 0.035. That's where it starts on the y-axis. So my base is going to be 0.335. Now all I need is my slope. So I can just use my slope equation. M equals y2 minus y1 over x2 minus x1. All right, so here for our values, we can pick 0.67 and then 0.0335 divided by 1 minus 0.5. 0.67 minus 0.0335, that's 0.63 divided by 0.5, because 1 minus a half is a half. So the slope is 1.2. Y equals 1.2 x plus 0.335. So that's the equation for that part. All right. Your aunt turns off the 375-degree oven and is cooling at a rate of 50 degrees. So the base for that one is 375, and that's in degrees, so that's going to be your y-intercept. And then the slope is 50, and it's coming down. Okay, so then that means we have the y equals mx plus b, and then y is going to be 50x, but it's cooling down, so that means it's going down, so it's negative, plus 375 degrees. All right, at the beginning of a local basketball tournament, there's 64 teams. After each round, one half the remaining team is eliminated. So similar to this one here, we start off with a base of 64 teams. And the slope is 1/2. So similar equation, y equals mx